Good morning, everybody. We are about to start the webinar in just a minute or two as we let the rest of the attendees join in. So thank you again for being a part of this. Just we're giving it a minute or so for people to join in. Hello, everybody. Just give us a minute as people are streaming in so that we'll be starting in just about a minute. Hello, Simone, I think. That's great. And sorry, I hope I pronounced your name correctly. And Zahir, we will take any questions on chat and Q&A. So feel free to um, ask questions. And there is going to be a good Q&A section at the end. And I'll go through that in just a minute. Okay, let's see. Let's just give it another 30 seconds. And that way, folks who are jumping off other back-to-back calls can join us. We know how that works. So I did get that Simon pronunciation right. So good for me. Okay, all right. I think it's a good time to start. And obviously, we will be recording this for folks that will be joining in later or view it remotely. So, good morning, good afternoon, and good evening, wherever you are in whatever part of the world. Thank you for joining us on this fireside chat. There will be a visual of a fireside, but I am excited to have with me Arun Subramaniyan. He is the CEO of Articulate. It is a very upcoming GenAI platform, which we'll talk more about, and really excited about the topic. What are the critical foundations for a scalable GenAI infrastructure? My name is Shekhar Iyer. I am the CEO of ArangoDB. We are very excited about a lot of the developments that have been happening in the industry and also to be able to share our thoughts, ideas, and examples that you can implement for successful GenAI projects. A little bit of more introduction about my guest, Arun. He is has had quite an illustrious career. He is a CEO of a spinout that came out of Intel organization. But prior to that, he was at AWS handling a lot of high performance computing capabilities. He, in fact, helped incubate the Anthropic solution from the early days. He was a number of years in GE solving real hard, complex problems. And he just happens to be a rocket scientist too. He's got a PhD in aerospace. And also, we will have a special guest, Renato. He will be joining us later on to give you a sneak preview into the technology. Here's the agenda that we have planned for you. I'm going to begin with a few opening remarks, and then we'll go into more details of who is Articulate and why does it exist. But really, the main thing that we want to capture and show, there's a lot of hype around GenAI and hundreds and thousands of companies. We want to show you the real deal. We want to show you how Arango has partnered with Articulate to really give you a solution accelerator that can make your GenAI projects successful with a high degree of confidence. And this is not all going to be slideware. So I think that's going to be an exciting part of what we have. And we will have some final thoughts and make sure that we can take some questions in the last 7 to 10 minutes that we have. So with that, let's get going. How did we come here? The thing that is really exciting, what we were able to do, is we actually had been working with companies and thought leaders like Arun and others in the industry, and we really felt compelled to write a book. How do you turbocharge Gen AI with graphs? And the beauty of this is that it really brought a very good focus and made us think, how can we explain the value of graphs in the Gen AI context? How does it bring more accuracy for these agentic solutions that are happening? And luckily, just literally 2 days ago, we got an Amazon bestseller status. And what we were also very excited about is Arun and Casey helped us create a case study in this book. So for those of you, you can easily Google it in Amazon. And the case study of Articulators here with, among others, NVIDIA and others are featured in here, how we are leveraging it. And this is something we feel you will get a lot of value about. Now, let me just take a quick minute to give you my thoughts and opinions on what I see is happening, emerging as the agentic architecture. We've heard a lot about this foundational layer. Obviously, ChatGPT took the world by storm and shook up a lot of things. And the fact is, AI has been there for decades. But what they have done is really make it much more democratic and usable. And you see a bunch of acronyms: LLMs, SLMs, small language models, video language models, domain-specific models. And really, it's all about the data, and there's company and proprietary data. The second part of the layer that I feel is the whole database, the orchestration, the workflows that are there. And then it's about those domain-specific applications and solutions. And while kind of the initial incarnations of this were chatbots and other things, this is also getting more sophisticated, but it also has to be very tailored to the specific domain, business domain, to get the end business user the benefits. So just to make it come to life, I kind of put some of the logos that you may be familiar with down here, as I mentioned, whether it's Gemini or Anthropic or the Llama. And obviously, we've had all kinds of drama with DeepSeek and other things that have entered into the market, and there will be more to come. So that's the only thing you can be sure of. And then again, whether it's the NoSQL databases or relational databases, graph databases, and obviously all the cloud storage databases that are there. And we feel there are three types of users on top. There are the next generation Gen AI applications like Gleans that's taking the world by storm. There are older companies like Adobe or UiPath that are trying to adopt Gen AI into their existing infrastructure. And there are so many yet to be determined custom applications that are there. But the important thing is, these are the elements that I believe, and just to put it in a simple way, there's obviously a lot of complexity underneath, but the whole idea is, how do we make it simple so you can appreciate that? That being said, the customers are struggling, and it's a mess out there. If you look at this whole flow from data to streaming to pipelines to object stores to data lakes, data warehouses, the Databricks, Snowflakes of the world, and then to create a domain-specific app, in this case, it's just fraud detection, there's a lot of work. So let me ask you, Arun, is this kind of what you are seeing, or what are your thoughts on this?
Shekhar, first of all, thank you so much for having me here. It's fantastic to be here. In fact, our second webinar together. And It's been like quite a fascinating ride we've had with Arango, especially. As we introduce what we do and articulate, I'll give you a little bit of a history of our association with Arango as well. That goes way before any of the hype started, to be honest. We've now, I think, running 9 years of actually running Arango in production. Um, this picture resonates very well with me and as well as pretty much all the customers we see globally in multiple industries. And we end up calling the left side of this picture really the data swamp. With all due respect for all the people who work in the area, including myself in the last decade or so, we've gone from databases to, say, materialized views to star schemas to, oh, data lakes will potentially solve your problem to, oh, you need, the enough data lakes, you need lake houses, uh, like to a point where now they all become data swamps. And across the board, the problem we hear from CIOs and business line owners is the fact that, look, I have a lot of data. I've gotten some outcomes from that, but I have not come anywhere close to the return on investments that I thought I'm going to get when I started the project, right? And that's a reality that a lot of leaders and a lot of businesses have to deal with.
No, that's kind of what we're also seeing, Arun. And there's the classical, should I build faster? How many things can I do? And we'll talk a little bit more about that. Given the state of the union, at least we're experienced, I know Arun and his team and many other colleagues of ours are experiencing. So that being said, um, here's the fact that currently for GenAI projects from pilots to production, the success rate is less than 20%. And I would love to ask the fundamental question, Arun, why? I beg you, why? Why is the question? Why is this happening if it's so amazing technology?
I think you're being very generous here, Shekhar. So I think the pilot to production rate across the board, whether it's a McKinsey report or an IDC report or anything you want to see across the board globally over the last decade, the pilot to production rate is less than 10%. And that is across all of AI/ML, right? So this is almost 15 years of development and ecosystem and partner development and people training and skilling and everything together. If you take GenAI pilots to production, that number is under 5%,
Hmm.
right? In spite of all the hype that's out there. And what we mean by production is things that are actually at scale, delivering business value in a repeatable fashion. Right? It's
Hmm.
not oh, I did a small scale POC, which is a word that we pretty much have banned in our articulate. At least we do not do POCs for a particular reason. I'll walk you through that. But
Hmm.
all the reasons that you've mentioned here, really, it is the complexity.
Hmm.
And it's super easy to get started. Very,
Hmm.
very easy to get started. It's almost ridiculously easy to show something that is super cool, but it just doesn't scale,
Hmm.
right?
Okay.
And
So
scale in many
then
ways.
and then just on that part, as you said, we are here to provide a positive solution. But the fact is, we have to be real, right? There is a, a kind of impedance to getting the business value, and it's not just cool technology for the sake of it. These are new skills and very rapidly changing technology landscape. So you need people who've been there, done that, can adapt quickly, use the things that already work. And I know this whole generic versus specific, and no matter, I'm sure a lot of people use open, AI and ChatGPT, but there's also certain limits to that. And maybe, let's get to this question. We are here to provide a positive solution to the state of the union. So let me ask you, who is Articulate and why do you exist?
So that's a great question, and the notion of who is articulate and why we exist because of the previous slide you had, which was we started trying to solve a problem for a customer at scale. And
Mhm.
it so happened that it's pretty much the same repeatable pattern that came across all more or less all the large enterprises, which is we are sitting on a large volume of data, which is reasonably complex. So even if you look at just documents, so it might just be a bunch of PDFs, Word documents, PowerPoint, whatever it might be, but the content in the documents are highly technical, highly
Mhm.
specific. It spans the range of simplicity of that domain all the way up
Mhm.
to really complex documents spanning sometimes thousands of pages, up thousands of different subtypes and all that. And the notion was, how do you go about building an application that is powered by all of the capabilities that you see in the consumer world? For example, today all of us can go log into, you mentioned ChatGPT or any of the other applications out there, and legitimately they give you value. Like, I mean, you can have one document, maybe you can ask a question, it gives you value. You have a paragraph that you want to rephrase, whatever it might be, it's a legitimate value add. But bringing that to the enterprise is not a trivial problem, right? So first of all, your data security is paramount. You can't really send anything out there quite yet. And even if you do, you're not really sure how do you take advantage of your entire corpus of information, right? And like even today, if you look at a case where you have few thousands of documents, not even say tens of thousands or millions of documents, just few thousands of documents. Now you want the ability to interact with your data and you want to generate new content. And if it's just a matter of, say, retrieving something that is there and presenting an answer, it's one thing. But even that is reasonably hard. All of us know how enterprise search is hard. But if you want to synthesize information, if you want your answer to be something that doesn't exactly exist in your data set, but you want to the ability to analyze and then come up with an answer that is a synthesis or an analysis of the data you already have. That is pretty much I would say, the quintessential use case across all enterprises.
Mhm.
And to your original question of why we exist to solve that problem. Today, the popular words for those would be things like deep search that's been
Mhm.
implemented out there, like where you can go ask a question and you pay anywhere between your $20 subscription to now all the way up to $200 or maybe where that goes. But that is still all documents that's out there you're analyzing. Imagine now in an enterprise, you have tens of thousands, if not hundreds of thousands of documents. You want to
Mhm.
be able to analyze it and power all your downstream applications.
Mhm.
That is really what we do. And in a one sentence description, we are a domain specific enterprise generative AI platform
Okay.
that goes into enabling enterprises to solve their core operating problems. So our primary focus is engaging with systems of record.
Mhm.
We seldom directly engage with systems of engagement. What I mean by that is, if we walk into a manufacturing company, we help the manufacturing company improve their manufacturing operations. Do they have things like HR and finance and legal and other departments? Of course, absolutely. And those could be secondary applications that our platform would support. But the primary application is the core of their operations.
Mhm.
And we'll give you some examples of where it goes, but you have a fantastic architecture diagram. I can explain it in this context as well.
Sure. So given that, I think that's a good explanation is obviously there's a lot of kind of challenges and you're trying to simplify, but in my simple little three-layered architecture, where does Articulate really fit? And is this where it fits?
That's a pretty good representation. In fact, a lot of people try to fit us in a box, and it's a hard thing to fit because we are a full stack platform, and our
Mm-hmm.
product spans across all of these layers that you have here.
Mm-hmm.
Uh, there are specific elements around it, as you have correctly laid out. The
Mm-hmm.
foundation of it is data and the ability to build domain-specific models and scale it. I'll come to that in a second. And then
Mm-hmm.
going all the way up to providing our customers, who are enterprises to a large extent, the ability to build applications of their own. But we
Mm-hmm.
also have starter applications that people can start with so that they don't have to just deal with APIs. So that's
Okay.
really what you see the top layer going slightly into the application space, but it's really a full stack conversation.
Sure. Now, obviously that foundational layer had this term DSM, domain specific. Tell us, and there were some pretty exciting announcements you made at GTC at the NVIDIA conference. Tell us what it is and why is all the hype around the generic foundational models not good enough in your mind, if you think so?
Got it. So first and foremost, I'm super grateful and thankful for the general purpose model providers, right? So especially folks at Meta with Llama or anybody who publishes their research openly, right? So
Hmm.
that is definitely Meta that actually completely opened up their research. It's really not their model alone that was most interesting. It's the research that they opened up.
Hmm.
Same thing with DeepSeek, where if you haven't read those papers, those are gold mines by themselves. So we're super grateful for that. Most of the other companies wouldn't exist without them publishing the research. However, the general purpose models are what I would term necessary, but not
Hmm.
sufficient to get to domain specific applications. And
Hmm.
think of it as an analogy. General purpose models would be, say, a high school student, a domain specific model that understands that particular domain, whether you are a mechanical engineer or you are a geophysicist or you're walking into, say, financial investments, you
Hmm.
understand that particular domain. That's would be the equivalent of a college graduate. And once you take those models and then go in and specialize it for a particular company, you
Hmm.
have an enterprise specific model that say codifies all the knowledge inside a company. That could be, say, for example, a principal engineer or a chief scientist in that particular company level of expertise. And I'll ask you a question, Shekhar, like say, like, would you go to an expert on any field, for example, whether it's, say, a brain surgeon, whose entire knowledge is only what has been gleaned from the internet?
Hmm.
Would you accept them as an expert compared to somebody who actually went to school, trained for it,
Hmm.
has knowledge that maybe perhaps would have been found in the open literature, but actually has training,
Hmm. Yeah,
right?
no.
And,
And one thing that Arun we've seen, as you're saying, is also there are industries like healthcare, financial services, regulated industries where they're going to even depend on domain specific or company proprietary, and they don't want to be, and there are even certain air gapped environments that's a whole nother domain to
uh,
work on.
yes, right. And like the example I used recently somewhere was like, say, somebody asks us a question. And the answer, even if you don't synthesize, is in a medical textbook. I read it. I have not done biology since my high school days, but then I
Hmm.
can find the answer using the indexes or whatever it is. I take the answer and give it to you, versus a brain surgeon who does the same thing, who reads the same book, but gives
Hmm.
you an answer that is nuanced, has the understanding and context of the domain.
Hmm.
Which answer would you want? An answer
Sure.
is fairly obvious, right? So that is really the difference between what we talk about general purpose models versus
Hmm.
domain specific models. Just because you can retrieve, just because you can display something, doesn't
Sure.
mean it has the same level of accuracy. So that's really have been our focus from the very beginning. And to the announcements, we actually were super grateful to announce that we've launched an energy specific, domain specific model in collaboration with the Electric Power Research Institute, EPRI, and NVIDIA at GTC. It's gotten tremendous traction. They also launched something called an Open Power AI Consortium. And
Hmm.
that's a great initiative where we've all heard about the potential crisis that AI has created because of the
Hmm.
energy hungry and power hungry chips that we have to put in place. But this
Hmm.
is an opportunity for the same AI to help alleviate the energy resources or energy crunch in the world. So these
Yeah.
models are built on EPRI's proprietary data, and portions of that would be open sourced and also would be used for optimizing energy globally.
No, that's great. And I know you're working on other models like the semiconductor and others. So good stuff.
That's right.
More to Um, just moving on to maybe the second layer of my cake. Tell us a little bit about all the next level details here that you're showing in this
That's
diagram.
right. Perfect. So this is like a bit of a preview into what you're going to see in the demo. So what we do at Articulate is what you see in the dotted box, blue dotted box here, where enterprise data exists wherever it exists. And we are not saying that we would disrupt where the enterprise data pipelines actually exist. So if you have your data investments in place, the promise we make to our customers is that they don't necessarily have to disrupt that. They get to take advantage of it. That's really what is on the right side of it. So there is
Mhm,
no copy of data that is made. What you see here is ingestion going to data perception, and relevant to this conversation we're having, which is the knowledge graph, is
mhm,
all of that is done as automatically or autonomously as possible. So very, very little human intervention. And to
mhm,
do that, we need a combination of different models to run. And that's
mhm,
where you see the model selection part, but that's done at runtime.
mhm.
And the overall orchestration is also done at runtime, depending on what you see. And the knowledge graphs being built are also completely autonomous. And the intent of doing all of this is the downstream applications that either a partner of ours builds, or sometimes we build, or a customer builds, is all powered by our engine, which continues to give you access to not only your data, but also the synthesis of your data real time.
Okay.
Okay.
Well, look, Arun, I think, it's 26 past the hour. Are you just going to show slides, or do you have some real technology that you're willing to
Af-
share with the audience
we
here?
After the introduction you gave, Shekhar, it's tough to follow, but we will sacrifice to the demo gods and go to a live demo.
All right. So
And
yes, Arun is booting up his thing. We have made some sacrificial offerings to the demo gods. This is real stuff, not canned demo. So as Arun is pulling up his demo screen, and here we go. What are we looking at, Arun?
Okay, so you're looking at our application that is powered by the platform underneath, and the data set that powered this knowledge graph is from EPRI that I just mentioned. And they gave us slightly over 10,000 documents across spanning pretty much every field of topic that the consortium covers. And you can see here that that many documents were uploaded here. So there's about 9,800 files. And each dot that you see here is already synthesized. So just to give you a sense of how that is works, all the dots that you see here are actually clusters. And each cluster comes from a group of topics that you see here.
Mhm,
And the topics are also auto-generated. So imagine that, say somebody reads through all the documents and says, okay, in each of these documents, these are the topics that are being discussed. And the topics are then getting summarized into clusters. So if I go into any of these things, they would connect to files. So this is a particular file that you see here. So I'll go back to the 3D just to show you where you are. But there is a topic came from a file. The file is getting broken down into all its constituent elements. Okay. And what you're seeing here are the clusters first. So these are all the cluster topics that have been generated. And the colors are groupings of clusters. So this is
mhm,
on top of the clusters itself as to how close or how far they are. And the
mhm.
distance where each of these dots are tells you how close or how far away each of the topics are.
Okay.
Okay.
So similarity of the clusters based on topic or
Yes, all of
got
this analysis was done automatically. So
it.
this entire analysis was done through our platform running on, in this particular case, it ran on about 64 GPUs. But the whole analysis of 10,000 documents broken down, by the way, into 400,000 images, 200,000 tables, 85,000 topics. And each of the images and tables that were automatically identified were summarized and connected together into a knowledge graph where powered by Arango with more than 4.8 million nodes.
Mm,
That is live.
okay.
And the distance here, of course, tells you how far or close they are. But the whole thing is also live, meaning I can go in and search a topic, something like, say, nuclear, for example. And the results that you're seeing here is live. So this search response came back from Arango, went through all the things, came back and rendered again. So what you're seeing here, this is the query I just typed. And this query is connected to your data set this way, meaning if I type a topic, you want to know instantly whether the topic can be answerable by the data set you have or not. How far or close is it, right? And these are all the different types of entities that came back. You can see there are topics that were auto-generated, there are tables, there are images, all sorts of things that came back, right? Now, if I hit on something like a table image, this is a table that was automatically identified.
Yeah.
And the
Wow.
summary was also automatically generated at ingestion. Okay. And if you notice, like these things can multiply very quickly because you may think that you have a document with only 100 pages, but then inside the document, there are hundreds of images or tables, then they're all connected and interconnected with each other. The interconnections are also automatically generated.
Yeah.
Okay.
Now, just to, did you use a domain-specific model to do the clustering?
Very good question. So the answer is there were two levels of clustering that is being done. Where initially we did not have a domain-specific model related to EPRI. So that was the intent. So you actually load all of this data in, you process it, break it all down, use that to actually build the domain-specific models. And after we built the domain-specific models, we validated with the scientists at EPRI. They're the ones who validated it. That's really why we jointly launched it. After the models were validated, the validated models were injected back into the platform, and all of the tables and images that were described were redescribed with the domain-specific models. So you have both the general description and the domain-specific description. We'll generally fall back to the domain-specific descriptions.
Sure. So
Yeah.
this is where for just the audience, I think it's really important. Generic models can obviously give you a certain model and clustering, but the domain specific gives you more because when you're dealing with this size, and this is while we're large, there can be even more. You want to make sure the end business user can get to the right answer quickly to get the insights. And yet, the other thing that is really amazing, and maybe you're going to show a little bit more, is the real-time nature of this because there's static and there's dynamic. So tell us a little bit about that, Arun.
Yeah, so the other thing that we built this also for is truly for people to explore their own knowledge basis and make sure that they can create new content and they can go in and synthesize, right? And that's really where our analysis area comes in. And so, for example, if you want to go analyze a particular topic, now if you are, say, even a newbie or you're a reasonable expert, but then you don't really know the corpus of information that is there for you to explore. This tells you these are all the potential suggested topics, by the way, which are also auto-generated as we were ingesting, that you could go start asking questions about. Say, for example, if I want electric vehicle adoption and infrastructure, I go ask that. If I know what questions to ask, I can clearly go ask. But if I want to know, hey, what questions can I potentially answer from the data I have, we constantly keep suggesting questions that could be answered from this. Right? So these are all questions that are generated by the system trying to say, look, it might be based on who the user is, what context they've asked questions before, and what is the data that is already there.
Sure.
And the whole
Sorry, Arun, to interrupt, but is it fair to say it's almost intelligent prompting? So if you don't know what to ask, is that
this
fair?
so this is in reverse, right? So this went from humans prompting the model to the model prompting the humans.
Okay. Yeah.
Okay,
Okay.
that's what is happening. And here, multiple things are happening. I'll show you another graph. This is a dynamic graph of how a question is being answered. So this is the actual question, and you came down to a few guardrails. I'll show you what they are. And then the system, what we call model mesh, it's a group of different models that have to decide what to happen at any point in time, decided to split the question three ways. And there are three simpler questions that are being answered first. And what you're seeing here live is to answer each question, there are references that came back. And the reason why it is coming back live and then you're seeing one coming one after another is every reference that came back is also scored. saying how good or bad is that reference, how relevant is it to answering the question at hand. And after the relevance checks are done, it'll go and start answering. But you can also see that our first order response is already back. And this is from a domain specific model that can reason. So it went in and said, okay, I'll begin by analyzing the question. What do I need to do? Here are the different things that are already there. And then came up with a final answer here. When you're actually going through what we call a high resolution response or a higher order response, which is generating live that you just saw, running through all of these different pieces. And if I want to go in and say, okay, observability, tell me what exactly is going on, every single step is observable.
Yeah.
Every
No,
single decision you're making is also observable.
sure.
And
No,
it's
that's a
critically.
really important part also. Like while there's all cool technology and all that, the one of the biggest, whether ethical AI, is if you don't have the linearity and the governance of how it's being done, the transparency, it's hard to get the right kind of adoption. And especially when you're dealing with business critical decision making, they need to have the confidence. So how do you handle that, Arun?
Yeah, so that's really where the scoring comes in. So every single response is scored, every single analysis is given a propensity score, if you may, because we can't quite say whether something is accurate or not. All we can say is the answer relevant to the question? Is the reference relevant to the question? And the reason we do that is the ultimate judge is the end user. They have to decide whether a reference is relevant to them or not. And then they also have to be the one saying, okay, you may think that these five references are what you would use to answer a question or provide an analysis. But as an expert, I do not want to use these two. Drop these two and then use the other three. So you can go in and interact and change. Right? That is
That's
really what we provide our users to be able to go do. Okay.
No, that's great. No, this is really exciting, Arun. And what I did, there is one question, and while we bring our other special guest, if you don't mind, unless there are some final thoughts you wanted to show
Not
here.
at all. The only thing I wanted to show is everything here is referenceable back. So I wanted to go back and show you, as Renato is coming up, that we can actually go back and anything that's an ID in the system,
Yeah.
you will be able to go back and forth. And we want to show you the behind the scenes of this as well, because we want to make sure that people take away from this that this is not just a demo. This is an environment that is in production, and it is all being powered by Arango, and I can go back to a resource at any point in time. So if I click on a particular thing, you will actually get that ID of that node in the graph that we've been showing you. So you can see the graph being loaded live and then coming back in here. This is the actual table that was referenced that you can go back into the graph, right? So
Brilliant.
I see Renato's here. We can
Sure.
show you
Why
the
don't,
backend as
if
well.
you unshare, I do have a question for you as Renato. Renato is our special guest, and he is also yet another rocket scientist. It seems Articulate has a monopoly on that. But Renato, a couple of questions before you're going to kind of show underneath the covers. You're going to make sure you keep your CEO honest. What is happening under the covers? But how long have you been working with Arango or graph technology, Renato?
Hey, thanks for having me as well. So we've been working with Arungo for a while, about 10 years ago. Um, it's been a long journey for us, working with starting as a document DB and then integrate with the graph DB and using the complex search capabilities that Arungo can give us. So it's been a while.
Brilliant. Do you want to maybe show us what is happening under the hoods? Because we're taking a deep dive, not just slides. We're going, and there is a question, and we'll try to answer it maybe Arun as Renato's. How much time did it take for you to prepare those 10,000 documents?
Yeah, so it was 11 and a half hours of clock time on 64 H100s, right? So the backend that was heavy duty was H100s, but the platform was running on it. And it was entirely autonomous, meaning there was nobody going and doing anything manual. So
Yeah.
everything from identifying, breaking things down, generating all of the downstream use cases. We had about 1% failure rate of documents that didn't go through, and that was pretty much all of them were documents that were created before 1960. So they're all scanned, they were at different angles, sometimes even pages being bent and all that. So the system said, I'm not that sure, I'm not going to do OCR it. But yeah.
Right. Thank you. So Renato, maybe I can even just ask a question. There may be people who are coming from a relational world, or you show all these fancy graphs. Why do you need a graph technology in the first place?
For sure, for sure. So especially for our use case here, right? As I'm going through here on the graph, where we have a combination of a different type of data, right? There's a relational connection between that data that our system automatically see and get from that information. So you want to be able to navigate and correlate as you're going through. Arun show you the demo live, as he type a word nuclear there, and that was able to bring back not only things that match the keyword nuclear, but also that have the context, the meaning, and also is related, is connected on that knowledge graph. And that you want to do that very quick, as you guys could see there happening, and under a couple of milliseconds, so you can bring that answer back to the user. You can only do that with a graph, with a knowledge graph. So what I'm gonna do here is I'm gonna Arun paste me the ID that he clicked that on the knowledge graph. I'm gonna load that live here on our Arango backend, so we can see that exactly part of the graph how it looks here uh, on the Arango database. So I put that ID here, so that's the ID of the node he inspected, and I'm gonna say, hey, I'm showing you the power of the connection of a knowledge graph. I wanna get 4-level deep connections. I'm limiting the number of connections because that can get very large. And I want to color by the node, sorry, not the, I want to color by the node type. And I'm going to apply that. That will load that graph, and then we can take a look at it, what that graph means. And I will explain a little bit. So this is all the nodes that are connected to that node that Arun showed. This is what's available to the platform, and can be answered in a couple milliseconds. So for instance, we can see that I'll click in one couple of nodes to explain what they are. Like Arun said, what are the clusters of information connected with that word, right? And if we look here, this is a cluster, and we see there's a title on that cluster. It talks about a different topic. If you go in other types of clusters, and I can see here that is also related with the other clusters and how they are connected, how do you bring that data back. These are all context important that you can bring for our model mesh to be able to answer a specific question. So maybe I can even go to a topic and see and show you what is the example of a text of a topic that was bring back for that node. So all the data that's correlated with the search that he used is bring back grounded on the user data and how they are connected. At that information, it is used at runtime, so we can retrieve bad information for the system.
Sure. Let me ask you, Renato, obviously you've been doing this and using Arango for close to 10 years. Why did you choose Arango?
That's a very good question. We actually use many different technologies, right? The place that Arango really shines for us is the combination, the multimodality of it. And I'm going jump to show a query example to show that. So I'll do the node transversal here that Arun showed with the node ID. So I don't want to get into the specific of the Arango query language here, but I'm just doing that's how simple it is to transverse a graph in Arango, by the way. I'm transversing that graph there, and I'm getting different types here. And the reason that I want to do that, it is to tell why this is powerful and why did we choose Arango. So as you can see, our knowledge graph is made of way different type of data. It is very heterogeneous. So combining a document DB, a graph DB, and a powerful search engine is the only way you can do that, and with the performance that you can do in 100 milliseconds, be able to traverse all of this graph and get all the elements that are connected to that specific node.
Yeah, so
When he
performance
says
and scale.
multimodality, right, here he's actually showing images, text, embeddings, topics all across in the same query, right? That is super powerful. But not only that, the performance is like you're seeing live. Like I just took the ID of a random thing I clicked on a graph. There's no chance I can find the same thing again. And he's basically showing that live.
Yeah, amazing. And then,
And then, sorry, go ahead.
Ronaldo, yeah, what would be kind of interesting for folks that are out there in this Gen AI or graph technologies journey? What are some of your lessons learned in this? Because obviously you're building some heavy duty enterprise applications here. So, as chief technology engineer, hands-on, unlike us CEOs, you know the good and the bad and the ugly. What
Right.
what is it that, what's the advice you have for people out there?
Thanks. So that's a very good question. So really, we try to rely on the shoulder of giants and good technologies. So, but when you do, you have to dig deep and see if that technology can scale. And that's one of the reasons Arango is really important for us. Uh, we can move quick with Arango. We can create very simple demos if you want, and people have been doing that as well. But also, you can scale that to very large numbers and still have the performance. For instance, on this example that we have here, I'm gonna do on this only for this account, only for the account that Arun it is playing with. If we run this query here, we're gonna see that as he showed, there's more than 4 million nodes on this graph for this account, not for the database, just for his account. And then you can only go to production with platforms that scale. So my one sentence that I can give is make sure that when you're doing your POC, you do with technology that you know that you can scale all the way to production. Otherwise, that are gonna be very expensive changes you're gonna have to do down in the lane.
Got it. Now, Arun, I know you are always traveling all over the world, conferences, and if somebody asks you, there are other popular graph databases, why did you choose Arango? Obviously, you're betting your business on it, but what do you say to those people and those who may have questions for you?
So a couple of things, right? First and foremost is scale, right? But then also the ability for us to distribute this globally. But I mean that both from the perspective of global reach, but also distribute it from a compute standpoint without having to worry about all of the underlying elements and know that this is being built by experts in graphs. We may be good technologists, we may think that we are great technologists, but then our expertise is not in graphs, believe it or not. We've worked a lot on graphs, we've used graphs, but we have no interest in going into the next level detail of how to make a graph database most efficient. And when we talk to Rango, we have no problems relying on Rango to go do that, right? And it's that complementary nature of scaling. And like for folks on the line, if you're wondering, okay, what does scale actually mean? The smallest graph we have is probably 1 million nodes. And by the way, that is just in one account, one tenant, one thing you're talking about. This is a multi-tenant system. We're running multiple things on the same underlying graph that is scaled, right? And the performance that you're seeing, it's not staged for this demo. That's what our customers expect.
Yeah. No,
And
thank you.
and the consistency that we've seen over now almost a decade, we've rarely seen from anybody else. We've now, by the way, like we've evaluated pretty much all of the graph technologies out there. Maybe one more knock, Shekhar, if you don't mind me doing that, is a lot of people today, because today graph is cool. It used to be not that cool because it was very hard to build. Now everybody wants to be a graph, so they can throw a layer of a graph UI on top of a relational database or a key value store and call themselves a graph. I would really caution people to think through what they take in. Because on the surface, it may look like, oh, this is also a graph. It's anything but.
No, very good point, Arun, and thank you, Renato. I know we're trying to get some Q&A, so what I'm going to do is get back to our program. There are lots of, as I call, Mickey Mouse solutions out there, and people trying to get with the cool stuff of graph and graph rag and other things. But I think it's really important that we can really kind of do real enterprise solutions. And I'm wondering, Arun, if you don't mind sharing the presentation here while I try to, we'll answer some of the questions that Christina and Santosh had,
Okay.
if you don't mind. And that way, just what is the power of, Arango and Articulate from your point of view,
Yeah,
and
so like really it is around a couple of things, right? So first and foremost, like what you saw in the demos across the board and what you saw really is what you're seeing as the autonomous data perception piece. Lots of big words, but really what we mean by that is without actually going in and doing any data wrangling by yourself, can you actually break down your data into its constituent elements and understand where things are actually going? And how they're connected. That's really
Mhm.
what we mean by autonomous data perception. But all of that was done by literally zero touch detection. The semantics of what is connected to what was also automatic. We don't know which images, which tables, which pieces of the documents connect to
Mhm.
a particular topic. That is very, very important. The multi-model and multimodal nature, so both the modality is different and models are different. I see there's a question about what happens if you have different domain specific models. Even to show that graph, there were different domain specific models. There's energy domain, but there's
Mhm.
also domains like, for example, you need to understand tables in a way that is meaningful. They all had to come together to go show you that. The
Mhm.
real-time observability, both on the dynamic side and on the static side, is super key. Now, we can't pretty much do any of these things without having an ArangoDB DB powering a lot of this because we rely on the ultra-fast responses to come back. And to show you a UI that works like how we showed you, maybe I'll mention some metrics, Shekhar, which is like we're running roughly about anywhere between 20 to 40 read and writes per millisecond into
Wow.
Rango. Okay, and that's really what it takes to get you an application that is snappy at
Very
this kind
cool.
of scale and has no problem scaling. So when you ask why Arango, that's the kind of load we put you guys through, and like we've been like super happy with it.
Excellent. Just one quick final topic and my final thoughts so that we can take questions here. I will say, look, it's been a real pleasure working with Arun and the Articulate team, people like Renato and Philippe and others and Gotham that I've had the pleasure of working with. They've gone through this and they were in this world before GenAI was a big hype topic. And what they're trying to do is build these solution accelerators, as you saw. It's a brand new world. It's beautiful out there, but it's also got risk. So why do you not want to de-risk it? The second thing which I'll say, which I love about the Articulate team, is they are battle-tested experts. It's one thing to have lots of fancy degrees, but these people have been building real applications, and you want to have that experience. Can I model it this way? How do you handle scale? How can I compress the scale, complexity into things? These people have been there, done that, seen it. And they've got that experience in large, medium, small companies building solutions and building it for companies they were in. And I think what I also really love about what Arun and the team do is they're they're not enamored with just technology. Yes, they may have chosen ArangoDB, but it's how do you create that business benefit and have that goal in mind and making sure you have all the right elements together to make that work. So really a big kudos, and what they're doing on the whole domain specific model will just up the level of success rate, the people that they have. And they keep impressing me every time, every other month I see he's got some new features. They are a very rapid, agile company. and really excited to be working, with the whole team. So thank you, Arun and everybody. With that, why don't we open up? I'm sorry, there's just a few minutes left, but we'll take as many questions as we can. And maybe there's a
There's
question.
one.
Yeah,
Yeah,
do you want to
there's a
take that?
question on the energy model's failure rates, and so really you can't necessarily call it failure rate per se. But then if you're looking at, say, a confusion matrix of sorts, we are right around the 96-97% mark for true positives, and at the false positive, false negative rate is anywhere between 3 to 6%. Right. And the reason why that number varies is it depends on whether you're looking at the specificity of a response versus a response that is vague, but that is vague because the underlying data is vague.
Great.
Right.
There's another
And
question.
yeah.
Sorry, Arun, there's just another question. Could you please explain the difference between your MREX and MOE in terms of, so you're smiling away, so I'll
Sorry.
let you
Yes,
have
I'm
at it.
smiling because I'm thankful to Henra for actually reading our website deeply, and really those were explained to make sure that we have. So there's a lot of there used to be a lot of hype at least a few months ago on mixture of experts. Everything was mixture of experts. Everybody was saying it's mixture of experts. The reason we went to a bit of a tongue-in-cheek mixture of real experts is if you look at the mixture of experts architecture, no expert or no so-called expert actually looks at the full data set. Every expert, quote unquote, looks at a portion of the data set, and it has access to only portions of the information that was trained from that portion of the data set. Whereas when you look at mixture of real experts, every model in that mixture is an actual expert. For example, the DSM we built for energy is one of the experts. It's not like that is broken down underneath into a mixture of experts itself. And then, for example, if we had another model for, say, aerospace, or another model for, say, fluid mechanics, or another model for finance, each of those are experts in their own respect, and then they can be mixed together to work in concert. That's what we mean by mixture of real experts. We can walk through some of the architectures deeply as well.
Sure. No. And please, folks, we are there's another question from Rob Bush. Can we set up a follow-up call? Absolutely, we can do that. And also, obviously, we will make sure you get all the contacts for Articulate. Casey will to field any questions or follow-up meetings that you want with Arun and the team. And likewise, Anil from our side, if there's any specific questions you have for Arango, happy to get into that. And also, just is there any other question? Anil, can we take live voice questions, or is it all through the chat? Just to make sure in case somebody's trying to do that.
I can only enable one by one, I think. I don't
Okay.
think I
Sure.
can.
Okay, we'll go through the
Please.
chat session to keep it simple, just given we have 3-4 minutes left. That's there. But I know that, what we're also excited about is, our partnership with NVIDIA. They're both our technology partner and our customer for Arango. I know, Arun, you also have some strong partnerships that you're working with there, and many other domain-specific models like semiconductor and others where you and your team have deep roots in and domain expertise, and many more to come as you're building and growing your team. So we have Anil and Casey's email. We'll obviously send out a note to everybody around this in case we're not able to get all your questions answered, or if there are follow-up questions that's not easy to do in a 60-second it's not the millisecond response that we do, but we'll make sure that we can catch those things. Okay, was there anything else or any final comments? I want to give you Arun and then Renato for being our special guests here.
First and foremost, Shekhar and the entire Arango team, thank you so much for having us on. It's been a pleasure working with all of you guys, and we look forward to scaling these into production across industries that have traditionally been very slow to move. That's really what excites us the most, and having real impact with you guys. So thank you so much for having us on. And I'll reflect on just the core expertise that the Arango team brings, which is also very rare, right? I mean, like in terms of doing deep research in graphs, that's really where the roots of the company come from, and then also been deploying it into production at scale. So kudos to you guys. Thank you.
Thank you. Renato, I'm going to give you the final word to you.
Thank you, Doug. Thank you so much, Shekhar. It's been, very nice journey with Arango. It's been helping us, to move fast on this area. So thank you so much for having us.
Excellent. Thank you both. And really a pleasure having you as partners. And we look forward to sharing more thoughts and insights. And as I said, happy to get on any follow-up comments, conversations that anybody is interested in. Thank you and have a great rest of your day. Cheers.
Thank you.
Bye.
Bye.